What is microgravity? Microgravity is essentially zero G's, or zero gravitational force, experienced on our body inside, such as a space station or orbiter. Inside the International Space Station, there is actually 88.8% of gravitational force still experienced. So why do astronauts float inside the International Space Station? Is because at the Earth here and the International Space Station, which is roughly 220 miles away from the surface of the Earth, as it is orbiting, it is always in constant free fall around the Earth. It is falling in towards the Earth, but it is also getting pushed to the right by the thrusters of the International Space Station. So as it's falling in, it's getting pushed away, and it continues to orbit and is in constant free fall. Therefore, the astronauts on the International Space Station experience roughly 0 G's, or microgravity, which is 1 times 10 to the power of -6 G's. A very, very small number. So, what can microgravity be used for? Microgravity allows for new materials to be developed and cannot be made on Earth due to its gravity. The new materials can speed up future computers, reduce pollution, improve fiber optics, and enable medical breakthroughs and cure diseases. So, what are some problems with microgravity? Well, anything that we do on Earth here is we take gravity for granted, picking up objects, putting them down. In space, you have nowhere to put an object down, because if you leave an object go for 1 second, such as you're brushing your teeth, you leave your toothbrush out, it could float away the next minute and you don't know where it is. So, one solution I have for this is to include a set of Velcros on the spacesuit, or pockets where the astronauts could place their everyday materials or tools that they need. They brush their teeth, take a toothbrush, put on their vest, wash out, put the water back in the water filtration system. They're good to go. So another problem with microgravity is daily functions such as sleeping, eating, exercising, or going to the restroom. During all these activities, you have to be strapped down or else you would float away, and you do not want to be floating away when you're going to the restroom. One other problem is the loss of bone density in space. This means that astronauts have a higher chance of breaking their hips or other bones later in life. It is currently solved on the ISS by switching out astronauts regularly on the International Space Station. But also there is going to be a current mission on the International Space Station with a group of astronauts that will stay on the International Space Station for up to a year, so they can experience a full spatial effect of microgravity and see how it affects their bone density. So microgravity is an issue for the entire mission, whether it's going from just out to space and orbiting a planet or landing on another planet, because they'll never experience the same gravitational force as we do here on Earth, unless the planet is the same size as the Earth, which we have no planets in our solar system that are the same size as Earth. So, from departing Earth, we will experience different gravitational forces, which means we have to have different systems for holding our materials and other things. Thank you for watching. Lastly, astronauts can be trained for microgravity situations by using microgravity simulations, such as flying a plane to a high altitude and dropping the plane, simulating microgravity. These training sessions can take place multiple times, and astronauts can get used to the zero gravity settings.